Hello. This video is all about units and what we use them for, types of units, things of that nature. Now, the reason we need units, for example, is relatively straightforward, I always think, but sometimes it bugs people. Let's say I said the distance of something is 10, and you can immediately see the problem with just that statement. Is the distance to a tree is 10. And the next question should be 10 what? Okay, 10 miles, 10 feet, 10 meters. So you need some kind of descriptor, right? You need some kind of descriptor. So let's say the distance to this tree is equal to 10 meters. Now, a meter is actually a defined unit, right? It's the way it is currently defined is it is how far light travels in a fraction of a second. The exact values aren't really necessary, but that is how it is described. And the speed of light is an exact value, right? It's actually the time that actually makes that a little bit uncertain, measuring that time frame. But a meter is actually a very precisely defined unit. And if you think about it, it makes sense that a meter needs to be defined, and it is actually defined by treaty. You may say, well, why would that be the case? But remember, units have a lot to do with trade. All right, and so people move goods around the world. They make goods in one country, which they ship to another, and then they'll make parts in one country, parts in another country, and then they'll bring those parts together in a third country, and they'll assemble them. They better work. They better fit together. In other words, the units better be correct. Okay, the same units in country 1 should be the same units in country 2 and in country 3. So units are defined that way. Now, there are two major systems that are in use today. There are other systems as well, but the two major well-defined systems, and the one we're going to use in this class is called the SI system. The SI system is simply a system internationale, and I apologize for mangling the French there, but the idea here is that it's defined as the units, by the units, and the unit of length is defined as a meter, which we can abbreviate with a lowercase m. The unit of mass, and this is not force or weight or anything like that, is defined as the kilogram. It's actually, I believe, defined by a cylinder of platinum iridium or something like that, which is, a thing that doesn't chemically change very much or anything like that. So it's abbreviated with a kg for kilogram, and the unit of time is defined as a second, which we defined as an S, like that. So this is the SI system. Now, your book actually has an additional term, which is electric current. Now, this is more of a physics 2 question, but it's an ampere, which is an A. Right? There are some other units as well defined, like what is a Kelvin, which is a temperature unit, a candela, and I believe there's one additional one. Now, the other major system that we use is the English system of units. And in that system, the length is a foot, which is also defined is a foot. Time is a second. Now, if you're really interested, this is always a good trivia question, is what is the unit of mass? The most common answer that people will come to is that it is a pound, but it's not. It is actually a slug. A pound is an English unit, but it is a unit of force. Right? Now, electric current is simply defined as an ampere. Oh, all electrical measurements are all done in measurements of electrical units like amperes, coulombs, stuff like that, are typically measured in the SI system. Now, there are additional systems. There is probably the most other prominent one is called CGS, which is basically just, it's a metric system where the length is centimeters, mass is grams, and time is seconds, right? And then there's some weird electrical units, which I won't even get into. We will not make much use of that in the class, but it does exist. So that is the basic units. Now, what these are referred to here, these units here, the meter, kilogram, and second, is they are referred to as base units, because essentially all other units are going to be combinations of these units. And we call these combinations of units, we call them derived units. So an example of a derived unit is speed. How fast is something going? And if you think about that in the SI system, that would be meters per second. If you would write this way, you would abbreviate it as a meter in a second. Notice what it is it's a combination of meters and seconds. In the English system, that would be a foot per second, which is a foot divided by a second, by the way. And so that's what it is. But there are other units as well. So, for instance, the unit of force in the metric system is in the SI system is a kilogram times a meter, referred to as a kilogram meter per second squared, which would be abbreviated as this kilogram meter per second squared. Now, this is used so often that it's given its own special name. It's given a name to honor a very important scientist, in this case Isaac Newton. It turns out that 1 kilogram meter per second squared is equal to 1 Newton, and this is something that you will use later in this class, is the fact that that's the case. Now, the unit of force in the English system is a slug foot per second squared, which is equal to a pound. And that is abbreviated with an LB. Now, you may wonder, how does it get abbreviated as an LB? Well, it actually goes to Libra, which is Spanish, which is a Latin word for scale, right? LB. So that's what it is. If you want to remember something, the constellation Libra is the scales, right? And so LB, that's where it comes from. All right. So sometimes these abbreviations come from, if they seem weird, they come from foreign languages. All right. So these are what we refer to as derived units. Now, here is a quick question for you. Okay, just to think about is, I sometimes ride my bike, right? So I rode my bike 1.6 times 10 to the 10 to the 5 centimeters, or 160,000 centimeters. This is 160,000 centimeters. How far have I gone? Now, before you make the trivial answer and say it's 160,000 centimeters, that's not what I mean, right? The question is, what am I describing here? What am I describing in this situation? Well, the thing is this is the difference between concrete concepts and abstract concepts in your head, right? What I want to refer to right now are what are called units of convenience. Units of convenience are where you have a unit where you can put the number into a convenient form, i.e. that the number that you get, that you use to modify that unit, will be a number that you can concretely picture. Now, what do I mean by that? Well, let's say I ask you to picture 10 apples. You could probably picture that right in your head right now. You can probably say, I'm sitting next to a desk. What if I put 10 apples there? You could see that, right? Your mind can form that. It's a concrete concept in your mind. But say I ask you, and you could even make some estimate if you just saw 10 apples, but let's say I ask you to picture the concept, picture 10,000 apples. What does that look like? What would a pile of 10,000 apples look like? You'd see a pile of apples and you wouldn't have any idea, right? Unless somebody told you how many apples were in there. You could do some calculations. Now, you can manipulate 10,000, okay, mathematically and stuff like that, but we prefer to have things that are straightforward, something in numbers that are close to small numbers, numbers we can picture, i.e. we can concretely picture this. Now, in case you're wondering, this is 16 kilometers, which is about 12 miles, I believe, is approximately that. I live over in Hornell, and so sometimes I'll ride my bike to and from here, and it's a 12-mile ride. Okay, that's a much more concrete number. Miles, in this case, is a unit of convenience. Yeah. Now, some other examples of units of convenience are something like the distance from the Earth to the Sun is equal to 1.49 times 10 to the 11 meters, or if you prefer, 149 billion meters. Well, that's not that helpful, honestly. That's a lot, right? It's a lot. And this number is absolutely important to know, for instance, if you're talking about things like in the solar system doing calculations. But there are other times when you want to describe the solar system, for example, with relatively straightforward numbers, something you can concretely picture. And so how do you refer to this? Well, you also can call this one astronomical unit, which is referred to as 1 AU. That. And so the distance from Sun to Jupiter, which is the largest planet in our solar system, is equal to 5.2 AU. And why does this help us? Well, if you think about it, right, here's the Sun, here's the Earth in its nearly circular orbit around the Sun. What I would do is 1, 2, 3, 4, 5, is if I wanted to draw the orbit of Jupiter to scale in the system, right, I would make a circle, and I apologize for the terribleness of my circle, but I'd make an orbit 5 times as much as Earth. So give you some idea of how far away Jupiter is. It's 5 times as far. See why these units are convenient. All right, this is a good place to wrap this particular bit up. I will have another video up soon. Bye.